So this is for reattempt students, right?
Yeah, this is for reattempt. We'll try to cover. I have already kept one session on Wednesday, but no one had joined that time. In morning, I just
Sir,
kept.
actually there was no message as such that session is
Yes,
there.
sir. We
This
didn't get
session
any
mail
link.
was given.
Yeah, actually, not forgot. I was, yeah, actually, I forgot to send you the announcement to all of you who is going to reattempt. When I joined that morning and I was trying to say, uh, anybody have doubt or no, and anybody have from reattempt for rerun qualifier. So everyone is for quiz 2 only. 11
Yes,
student
sir.
prox have joined that time. So let's
So today you're going to take only doubts or like conceptual things also.
uh, uh, I will try to cover like it is kind of revision session. So one thing you can do, like you can watch the older revision session which have already done. Two sessions we have already. And second thing, in this session we'll try to cover week 1 to 4. So we quickly revise the thing, like what are the functions, symmetry, what are the what are the
So
sets,
you're
application.
going to take topic wise revision like
Yeah,
from week 1 to week
topic
4.
wise. Week 1 to
Okay,
week
sir.
1.
Okay.
That's the process will.
Answer
Okay, so let's, yeah.
doubts.
So yeah, so uh, I will say then maybe I will take first doubt, because who is came here for just for doubt will quickly resolve, and then we'll start the revising thing. That's one thing I think I'm thinking to do. So I will take first
Oh,
doubt, then we'll start the revision. Yeah, just a minute. Let's wait 1 or 2 minutes, then we'll start. Yeah, okay. So this is reattempt. Many student.
Yeah,
Let
sir,
me
we are done.
share my screen. Then we'll start now. This is okay. So detail, rerun or reattempt. Reattempt session. Okay. So yeah. First thing I will say, raise your hand one by one. Who have doubt will quickly resolve. try to resolve and then we'll move on to the discussing. So yeah, Asif, what's your doubt?
So my doubt is in activity question 4, first question, sir. It is a projectile motion.
Okay. 4.1.
In no sir, 3.4, sir. 3.4 graded assignment in quadratic equations, sir.
Okay. Which question number? This one? First one.
Yes, sir. Yes, sir.
So in this question, what's your doubt? Like where you are facing difficulty?
Sir, I cannot find you, sir.
You.
Yes,
So
sir.
what was like, let me first read out the question. A stone is thrown with an initial speed is u as assumed. Okay. The figure. The height of a stone is given as a trajectory in this fashion, which is a function with respect with respect to time and speed, initial speed. If the highest point in the air that stone has reached is 5 meters uh, above the ground, then calculate the initial speed. So this is one thing is given highest point. So did you use this one? If you
Yes, sir.
have,
I used, but I cannot find it. My answer is wrong.
oh, so you tried, but answer is wrong. So maybe you did
Yes, sir.
maybe calculation mistake, then that's all. Because if you know the procedure, that is not a
Yes, sir.
big.
I know the process. I know.
So what you can do, like highest point, so just divide, the axis of symmetry, just find the axis of symmetry. What is going to be axis of symmetry? Let me solve with your terms. So can you tell me what is going to be the axis of symmetry in terms of t? What would it be? Minus b by 2a, right? So minus
Yes,
b
sir.
by
Yes, sir.
2a is 1 by 2
Minus d by 2a and minus d by 4a.
minus 1 by 2 u
Yes,
minus
sir.
b by 2 into a. What is a here? 5 minus
A
5
is 5.
minus 5. So it is going to be 1 by 4 u, right? Sorry, 1 by 20. 1 by 20 u. Now it is given that this is the axis of symmetry. At the axis of symmetry, the highest point will be, you will get like highest stone will be reached to the highest point. So which is given 5 meter. So just substitute in the equation what you have. ht is equal to minus 5 t square plus 1 by 2 u2 u. So just substitute here 1 by 20 u whole square 5 plus 1 by 2 u, it will be again u by 20, and it is 5 meters is given. Now solve this equation. It is a quadratic, I think. Now you can solve for quadratic, you'll get u. That's all. Maybe
Yes,
I,
sir.
yeah,
Okay, sir.
yeah.
I will do.
Let me go with the next one, which is ABC. What is the name ABC? Oh, sorry. Can you tell me what is your name? ABC. You just raised.
Aman, sir. Aman.
Yeah, hi, Aman. So, yeah, what's your doubt, Aman?
From previous year.
Sorry?
Can I share my screen?
Sorry?
From previous year, sir. Previous year question.
No, I'm not getting. Can you repeat again, please?
I have doubt in
From
previous year question.
Sir, he's telling previous year question.
PYQ, sir, PYQ.
I have doubt
previous,
in
the last, whatever the qualifier had had.
Yes, sir.
So what is that question? You can tell me, because I am unable to reach
Sir,
exactly
can I share
question.
my screen? Sir,
Yes, yeah.
can I share my screen?
Yeah, no, I don't think you are you are allowed. So what is that question? Can you tell me? I will quickly get that, I think,
Okay.
if you just tell.
Two highway perpendicular to each other.
Two?
Two
Uh,
highway perpendicular to each other.
okay. Two highways perpendicular to each other. Okay.
Are considered as a coordinate.
Okay. Just read out the full question. Okay, just a minute. Then what I can do, just a minute. Question paper and answer. Which set it will be? This is CT. Okay. Time, okay. Okay, let it be downloaded, then we'll see. This is English. This is what? CT English.
In the last, sir. Last.
I think it will be in last.
Mhm.
You're saying in last it will be okay. This is maths one. Okay. Which question number it would be? Perpendicular to highways. No. Which question number is? I'm not able to see.
Question number.
Highway, right? What is the initial words in the question?
Two highway perpendicular to each other are
Two
considered as a
highways. So
coordinate.
this happened in this 26 Feb.
No, sir.
Ah. Oh. Okay. Okay. So I'm not sure then how I will get that question, because this I just opened, this one is from this 26 Feb. It have happened.
Sir, can I share
Okay.
the document? Document I have.
Yeah, you
Question
can
document.
share in chat.
Okay, sir.
Whatever you have, just share in chat. We'll see. Okay, who is the next one? We'll one by one. We'll get I will get your question. We'll discuss that. Mohini is the next one. Yeah, hi Mohini.
Yes.
Yeah.
So the last question, 11th one that happened on 26th Feb.
Oh, in this question itself. Okay. This one.
Sure.
Okay. So in this question, what's your doubt? Like a figure shown fg of three polynomial of degree is given on xy plane, and fx minus gx is given again some polynomial. Okay, where a is not 0. Okay, here it is written. If v is a negative constant, then choose most possible expression of hx other and the other correct statement among the given options. Okay. You want to find the hx and fx at okay. So this is your hx, which is a quadratic, function. It's in the picture itself it is showing. Okay, so what it's needed, what in this quadratic, this is given the one root would be greater than it would be negative, and the another root it would be the intersection point, this one and this one, fx minus gx. So one root is, so in between two roots, This one is, I'm not sure about it. It is from the figure. See, the hx lie in between the roots, which is roots means intersection of f and fx and gx, right?
Yes, sir.
What are the intersection points are here? So at the intersection point, fx minus gx will be 0, right? Fx minus gx would be 0 because they are intersecting at that point. Means values
Yes,
are
sir.
the same. So here and here the values are same. Okay.
So wherever they are intersecting.
So this is the point, right? This one, no, this is blue line, blue curves is for fx and the red curve is for gx.
Sir.
Okay, this one is for fx and this one is for gx. So this point is intersection point. This one, 4 points are intersection point. So see that now at 4 points both have value same, right? Fx and gx will have same value at the intersection point. Fine? No?
Yes, sir.
Okay. Now see that fx minus gx is given the polynomial. This polynomial is given. So what would be now so where they will intersect? So fx minus gx will be 0 because at value will be same at those points. Intersection point, the value will be same. Then fx minus gx will be 0, right? No?
Yes, sir.
So
So
the
basically what
values
you're
will be
saying,
that means
ba-
whatever this polynomial is given, so
Is equal to
whatever the roots will be of this polynomial, those points will be the intersection point because fx minus gx is given.
yes,
So
sir.
if you want to get the intersection point, so find the roots of this polynomial. That's all from here.
Okay.
So that means one root is 0 because here this one x is equal to 0. Another root is 2. Another root is 5 and this one is going to be your 10. As here root is 0 for this one, root of this
2,
polynomial
5,
will be
and
0,
10.
2, 5, 10. So that means here here is 0, it will be, this will be 2, this will be 5 and this will be 10. Now try to guess the function hx because one is root is in between 5 and 10. So which hx give the root between 5 and 10? Is this one? This one? Which one will give? What is the root of this function? If you use the if you make a fraction of this quadratic, so it will be 7. Let me solve it here. X square minus 6x minus 7. So this would be x square minus 7x plus 1 plus x minus 7. This you can write this polynomial. Now x can take common. So x minus 7 plus 1 can take common. So this would be x minus 7 and x plus 1. Yeah, one root you are getting in between 5 and 10. Correct?
Yes, sir.
And one root is going to be minus 1. So see that the graph, this is apart from 0. The another root is from 0 less than 0. So here it is something you'll get. And now just compare. No, so what about this one? What is going to be the root for this one? Just compare. So it will usually just, you can neglect the option x
Okay.
square plus 8x minus 7. So what would be the root for this quadratic? So it could be solved. Now you have to solve with the, now you are going through the polynomial or quadratic. So minus b by 2a, or minus b plus minus root over b square
Minus 4 AC.
AC upon 2a. If you substitute, then you will get the root. There is
Okay.
no process to get. So I think the roots will be, I don't think the roots will be in between 5 and 10 when you solve this. Only this one is giving the roots between 5 and 10.
Then,
As
sir, we
said.
have to.
hello sir.
Yeah,
Hi,
hi.
sir. Sir, I send the PDF.
Okay, okay, okay. So by this way, you will able to. Are you able to get that right? How the what will be
Yes, sir.
the by this way? And the another option is, as I just now said, at these points, the function value will be
roots.
same. So that's why fx and gx will be the same at 0 to 5 and 10. So this option will be the correct option. These two options will be correct.
Okay,
Okay.
sir. Thank you.
Yeah. So let me see the next one. Amra Fatima. Yeah, Amra Fatima.
Sir, this same, the one with the SSC, could you explain how to do it? Because I saw the lecture and I didn't understand how to do SSC.
Okay. Where is that PDF, Aman?
It's the same thing.
Yeah, okay, okay. Aman is saying something. Where is that PDF, Aman?
Yes, sir. I
Share
sent
the
to MA 101.
MA1
MA 001.
to my email. I
No, sir,
think
in the chart.
in the chat itself. Okay.
Yes, sir.
New message. No, okay. I did not get any message. Here I am looking. At which time you sent? Directly message, okay. Yeah, now it came. Let me open it. Okay. So which question number is this in this PDF? Yeah, hi, Aman.
Yes, sir.
Which question number?
Folder.
Highway. So one thing, this is the old question, no? So did you watch the, am I audible?
Yes, sir.
Two highways perpendicular to each other are
Yes, sir.
considered
Yes,
as the coordinate axis, okay? Arpita's house is at the point -3a and his friend's Pooja's house is at the point -310. The distance between their houses is 6 km. Sophie house is at B10, B comma 10. The distance between the Pooja's and Sophie house is 8 kilometer. If A and B are real number, then what is the distance between the Arpita's and Sophie's house? So this is just based on the distance between 2 points. So what's your doubt here for
I
this
can't
question?
understand the procedure.
The question itself, okay. Okay. So what is the two highways perpendicular to each other, and the perpendicular you can think on as a axis itself. It is saying consider as the coordinate axis. Okay, so
Yes, sir.
let's say, so this is, suppose this is one highway, the another highway is this one, x-axis, and this is y-axis, as the question says. Now Arpita's house is at the point -3a. Okay, -3a. So this side will be, let's say here is -3a. Okay, let's say here is -3a. And the that one is Arpita's house, and the Puja house is at -310. So this is here Arpita, and -310. Let's say here is -310 is Puja house. Okay, just quickly you can indicate on the plane itself. The distance between their houses is 6 km. Now 6 km is given in between the distances. This is 6 km. So can you guess what would be the A now? Because -3 and -310 is point is given. So what would be the A? Can you guess what would be A here? Because now you need to, on this line, 10 is given and A is given, 6 km is given. So what would be A? A would be 4, right? Then you will add 4 and 6, then it will be 10. This distance will be 4. Then it would be the final whole thing is going to be 10. No, Aman?
Yes, sir.
On the same line, because -3 is the point, Arpita's house, and Pooja's house is -3, 10. So they will be lie on the same line, vertical line. And the
Yes,
whole
sir.
-310 will be this height. And -3 we don't know what is A, but this distance is given. In between distance is given, which is 6 km. So what is now going to be the remaining? 10 minus A is equal to 6 it would be. So A equal to here 10 minus 6, which is 4. Now similarly you can get for another one. Sophie house is which is located at B10. So B10. So height is saying to be the same. I don't know where is B. Let's say B is here. So B10. Let's say either maybe here it would be 10. We don't know what is the B positive or negative, but height means this distance, this on the y-axis distance. This is 10, this is 10. On the same level they will be. Okay, on the same level -3 and -3a and -3b, -310 was there. So now again the distance is given what? The distance between Pooja and Sophie is 8 km. So 8 km is given. This distance is 8 km. So -3. So now you can subtract B minus 3, it would be here 8 km. That means B plus 3 is equal to 8. This implies B is equal to, it says 5. So 5, 10 it would be. So now what is the answer now? So what is the distance between Arpita's and Sophie house? Now you have the point, no? This point is -3 and 4. Now A is become 4 and this point is 5 and 10. Now the find the distance between in these two points, just use the distance formula.
Okay, sir. Thank you, sir.
Clear?
Yes, thank you, sir. Actually, I don't get how to do.
Okay. So the next one is I think, where's the next one? Oh, just now I am. Yeah, Amra Fatima. Sorry, yeah, Amra Fatima.
Yes, sir.
Yeah.
It was from that question paper of this 26th February qualifier, the one with the SSC question.
On which held on 26. Okay. Which question number?
Uh,
Which, or even you can tell the question itself. We will get that. You will get that. No.
1 second.
Yeah. Okay, let me go with
It
the
was in the
next one.
second one.
Okay, second one.
Second set.
Second set. So no
Yeah.
worries.
The sixth
Question you
question.
can now tell, no? Yeah,
Sixth
question itself. Yeah. Fifth question.
Sixth question.
6.
This one.
What is
Yeah.
the? Can you read
There,
out the
it
question?
went up.
SSC 1.
Okay, this one. SSC best fit
Yes.
line. Okay, so what's your doubt here? Are
I
you
didn't understand how. Sorry.
uh, yeah, continue. Yeah, further.
I didn't understand how to do this question.
So you know the concept, SSC concept,
I'm
best
not
fit
thorough with
line.
it. No, I didn't understand the lecture either.
So SSC mean to say, if you have, let's say, let me quickly tell. Suppose you have a collection of points, okay? Okay, some collection of point as, so this is the collection of, these are the points. So let's say this is I have just collected in this table as here, in the table itself here is saying. So one point will be on x-axis, the another point will be y-axis, right? So let's say I have just collected these points as here, okay? Now I'm suppose some lines are passing through in between the, okay? So which line would be the best line in between these points? Okay. So how you will is, yeah, how you will find this one? This is the mean to SSC means. Now how will find the exact line which will be suitable for this point? What do you mean by suitable? Mean to say means which will be the, like, if you find the distance between the this point and this line, and if you try to find the distance between this point and this line, so which give the minimum distance in between when you compare the this line and this line. So I have to find such line which will be the suitable, which give the minimum distance between the point and the line, whatever the points are there. So whatever the possible given points are there, okay? So let's say this one and this one. So if you calculate this distance, suppose I'm saying this line is going to be the best line. Why? Because if you calculate the distance between this point and this line, it will be minimum. Rest all, if you try to calculate this line and this line, it may be lesser, but for other point, it will be away. So
Sir, so do we have to find a line roughly in the middle of all the points?
yeah. So you have to find a line which will be the middle, which will pass through, which will give the minimum distance. When you find the distance, when you add the distance between all the points and the line, and which will give the minimum, that would be the best fit line. So what is the process? The SSC is a procedure. SSC is this is a method to find the best fit line, means in between whatever the lines is given, which line will be the suitable for these points. So how we'll find that? Suppose that this is the line, equation of the line is y is equal to mx1, mx m1 x plus c1. This line is y is equal to m2 x plus c2. This line is y is equal to m3 plus m3 tx m3x plus c3. This line is m4x plus c4. Let's say y is equal to, this line is m5 x plus c5. Now what is the SSC formula? What you can do? Y minus m I x. So for suppose for this line you want to find the SSC for the first line. So what you can do? Y minus m and 1 x, okay, plus c1. We will take the square each time and sum over, let's say, so these are the points is given, right? These are the points is given. So these values, let's say x values, and this row is for y values. So suppose this is x1 is given, okay, x2 is given, x3 is given, x4 is given, y values are y1, y2, y3, y4 is values given. Means one point is x1, y1, another point is x2, y2. So these points are given. So that means just substitute the values x1, y1, x2, y2 in this fashion. Let's say now xi I am saying, and sorry, yi and xi I am saying, and sum over whatever the points, let's say 4 points are given, so sum over 4. Just substitute the values and take the sum, square and take the sum. So suppose this gives 50. For this line, let's say the same sum will give 60. For the another line, some value give 30. Similarly, for other one, let's say 40, 30, 60, 70, 55. Other for others line, these sums are given. So which one is minimum in between the sum? 30 is minimum, right? In between these, when you calculate one by one for each line, this sum. Am I audible?
Yes, sir.
Yes, sir.
And what I'm telling, all of you are getting, or maybe Fatima is getting or not?
Not really, sir.
Okay.
How do you calculate M? Like, what is the value of M there?
So M is actually, just assume that no, the equation of this line is, let's say y is equal to 2x plus 3. I just assume for the particular, this M value will be given, M and C value. Let's say this equation of this line is 2x plus 3. For this line, let's say 3x plus 5. Similarly for other one, y is equal to. So for other line, so 2 is here. What is your M1 here? M1 is 2, C is 3, C1 is 3. So assume these points are real, given for you. These values are given. Only x and y are variable, no? So don't worry with this one. Okay, this value will be given. Now if you substitute here, the points are, what would be y1? Okay, so let's say here is your equation. So sum over I is equal to 1 to 4 yi minus 2xi minus 3 whole square. For the first line, I am trying to calculate SSC. Okay, so now substitute here.
Sir,
1 by n, what would be? Yeah.
Sir, here is a minus C, no?
Minus C.
So
Yeah,
in
minus.
formula.
Oh, sorry. Yeah, in formula, it will be minus C. Yeah. Yes, it will be minus. So here, what would be value here? Y1 minus 2x1 plus minus 3 whole square. Now, and next sum is sum over 1 to 4 is given. And y2 minus 2x2 minus 3 whole square. Like this you will do, and you will find the sum. So suppose your first sum is 40 for the first line. Similarly, for the second line, 60. Third line is 30. Fourth line is 70. Fifth line is 55. So which one is minimum in between the sum? 30.
30.
Correct. So for 30, this line is 30. So that means which one is the minimum? That is going to your suitable, which give the minimum sum square error. That would be the suitable line. So that's called best fit or SSC, or sorry, best fit line. So as this 30 is going to be the minimum, that's why the best fit line is going to be this line, which is going to among the whatever the lines is given. Correct? Or getting, no? What do you mean by SSC?
Yes,
or so now you can try for this question. Okay, just try once now from your side. Okay, that's why I ask, are you getting what do you mean? Because this question is not tough. Only just need to find the SSC.
Sir, was this the formula? The y1 minus 2x1 minus 3, the whole square plus.
Yeah.
That's the formula for SSC.
So this is the formula. Suppose equation of a line is given, this one. So for SSC, so for SSC, the formula will be yi minus mxi minus z whole square.
Sir.
Okay, so why are we adding it? In the above page, you added.
Because points are given, no, 1 by 1. This is 1 point, this is 1 point. So you substitute each point's value in the here, as here in this box is given. So this is one value x1 y1, this is x2 y2, this is x3 y3, x4 y4, x5 y5. These values are given. This vertically, this the 2080 is, let's say,
And these points represent a different line, is it?
no, these points represent these points here. These are the
Oh,
points.
okay, the scattered
22.
points.
A scattered point.
Okay.
And in between the line is here given, no? One line is here. And maybe some other thing is also, I'm not reading out the question, something more, some other things are also given, some other line may be given. So in between, using that best fit line, you need to choose.
From this equation, we get
yeah, maybe it is saying this line is the best fit line, something is missing, you need to find the, okay, for this line, you need to find the SSC, just need to calculate the SSC. You need to find the
M is 5 and C is 22, right?
Yeah. Yeah, it is. So for this one, this line, it would be y minus 5x minus 22. So y minus 5x minus 22 sum over you need to find. So this is xi, this is yi, this whole square. Now the points is given there. So x is for, I think, for kilometer, and this value is, this below one is for x values, and this above one, I think, y values. So 1 y1, you need to substitute it, try to get the SSC. That's all. Okay, Fatima?
Yes, sir. Thank you.
Yeah, just try once. Now I think you can solve. Just now, I hope you got the idea what do you mean by SSC, right?
Yes, sir.
Okay, next one is Wajid Ahmed. Yeah, Wajid.
Yes, sir. Am I audible?
Yeah, you are audible, Wajid.
Actually, the question is in this last qualifier.
Last qualifier. Okay. This is the question. This is the last qualifier, 26.
Yes. Rubiga launches her new company in the year of 2010. That one.
Okay. Okay, this one.
Yes, sir.
So Rubica launches her new company in 2010. Which make a yearly profit in some polynomial. This is the profit polynomial is given. Polynomial, whatever the polynomial is given, that is a profit thing for the first 12 years since the launch, where x is the number of years. That means from x is equal to 10, notation is given. 10 0 value for x equal to 1, the year will be 2011 and so on. Let the loss be represented as minus v of the profit. Which of the following options are correct? So the px is the profit or loss polynomial, you can say, right? Rubica launches this company yearly, which makes a profit, which makes a yearly profit in lakh as the polynomial is given here. So what would be the profit or loss? This is the polynomial is given. This information you have. That's all from this in this question. This information we have. Now you need to find the options. You need to check the options, including the year in which the company was launched. It's neither made a profit nor a loss 6 times in 12 years. In 12 years. So in 12 here, just find the value. Okay.
Value
in 12 here, yeah, no, the profit value. It says the including the year in which the company was launched. Okay. It neither made a profit nor a loss 6 times in 12 years. In 12 years means x is equal to 12, it will be in 12 year
Sir, is
because
this
12
section
year
for
means,
qualifier only?
yeah, this is for qualifier only.
Okay, sir. Will there be any discussion for quiz 2?
No. We are already done with the quiz 2 in morning. When there were 2 sessions, both sessions have done for quiz 2.
Okay, sir. Thank you.
So if you substitute x is equal to 12, what would be the profit now? Because in 12 year, something is given. It will neither profit or nor loss in 12 year. It neither made a profit nor a loss. So in 12 year, what would be, this would be correct? In 12 year, it will give neither for a first 12 years since the launch, okay? Including the year in which the company was launched, it neither made a profit nor a loss 6 times in 12 years.
Sir, I think we have to substitute the value of X
Yeah,
for each year and then find out if there is profit or not.
Yes, 6 times in 12 years. Including the year in which the company was launched, it neither made a profit nor a loss 6 times in 12 years. 6 times in 12 years means here is this. Okay, just a minute. Including the year in which the company was launched. Okay, so each year you need to substitute and you need to find the values for 12 years. Okay. Including the year in which the company was launched. So it launched in 2010. Sorry, 2010. Okay. Okay, was launched. It neither made a profit nor a loss 6 times in 12 years. In 12 years. Okay, the second option is the company made profit in years. Okay. Okay, 7, 8, and 10, 11. The company made profit negative, means loss, in year 5, 6, 7, 8. Okay. Okay, in these values, just need to substitute. Once you substitute values, you will get the idea in which year it will be neither profit nor loss, in which year it will be the profit, in which year you will get the loss. In year 2022, that is x is equal to 12, the company made profit. So for this one, you need to find each time you have to substitute and try, you have to find the value, like for when you substitute x is equal to 1, 2, 3, 4, 5, and after 5, you need to substitute now 5, 6, 7. Once you substitute the values, no, because each time as here it is given, so you have to find the values. So it is positive or negative. You based on that you will choose options, and based on the values also you will check that okay it is going to be the neither profit or nor loss at the 12 year or not. So at the 12 year 6 times.
So when P of X is equal to 0, then it is
neither profit neither loss. Yeah.
So sir, X is equal to put 12.
Here is here is not 12. You have to find the values for 5, 6, 7, 8, 9, and 10, and you need to add all them. Okay. So once you add, what is going to be your is this positive or negative? That's the here says 6 times in 12 year.
Okay, sir.
You need to add, then you will get that it is going to be profit or loss. Okay.
Okay, sir.
Just try once. Okay, let me see. The next one is Bharti Mohan. Yeah,
Yes,
hi,
sir.
Yeah,
It's
hi.
me. Hi, sir. Sir, same 26 February, question number 5, sir.
What is that question?
We have to find out the distance, I think.
Between? I think this one.
No, sir. Question number 5.
Can you read out
Not,
the question?
no, sir, not this one. Sorry, I didn't.
Can you read out the question?
I don't have. Can you go little bit down, sir?
Okay. Down or up?
Yeah, this one.
This
Question
one.
number. Yeah.
Okay. Assume the ball was thrown from the point. We have point is given 0, 4 on XY plane as shown
Yeah.
in the figure 1. The ball reaches the maximum height 6 meter and it's returned to a height of 4 meter after 2 seconds. This equation is written here.
Yeah.
The quadratic. You need to find in this question quadratic. Exact quadratic.
Okay.
Okay.
Can you explain this sum, sir?
So the ball reaches the maximum height 6 meter. So can you find the axis of symmetry for this? What would be the axis of
Vertex?
symmetry? Vertex, yeah. So axis of
Uh,
symmetry,
minus b
yeah,
by
first
2a.
find, yeah, it would be minus b by 2a. And the second one is just when you substitute the value, what is going to be the vertex? So what is the vertex here? Minus b by 2a, and y values will be
6.
1. 6 is maximum height. Okay. Maximum height. Okay, fine. 6 is given here. Okay, b. Okay. So vertex is minus b by 2 and 6. Fine. Yeah, this is correct. Now, after 4 minutes, sorry, after 2 minutes, it reaches the height 4 meter. So if you substitute h2 is equal to 4 meter, height is given, no? Height and relation between height and time is given. So h2 is equal to 4 meter, correct? So that means
Okay.
here 2, what is that? 4a.
At
4a plus 2b plus c is equal to 4. Correct?
yeah.
And
Yes.
this is the maximum height once you substitute in the equation x a t square plus bt plus bt plus c, that is actually c as height is given. So when once you substitute in this equation a into b upon, I think 4a square, b square plus 4a plus b into minus b upon 2a plus c is equal to 6.
Okay.
Using this equation, try to solve. Maybe, yeah, it will be solved now, I think.
Yes,
Now,
sir.
from here,
Thank
you
you so
can,
much, sir.
yeah, just try once.
Sure, sir. Thank you. Thank you so much, sir.
Yeah. Now, let me see. No one is the next one. So now let's start to revising the thing because I just try to get over your doubts, then thought to revise. Yeah.
Sir, can you repeat this question? My network is some issues, sir.
Okay, so see, the height, maximum height is given, and you know the axis of symmetry. At the axis of symmetry, the maximum height is there. So that means axis of symmetry, which is minus b by 2a. If you substitute in the equation, that is the maximum height, as here. This one. One information is
Okay.
this one. And the
Okay, sir.
second
Okay, sir.
information is after 2 seconds, the height is 4. So that means when you substitute in the equation, this information you have. So using these two equations, you need to solve A, B, you need to find A, B, and C. And maybe some other information is there. Okay, 0, 4 is given. So C, what would be C here? From directly you can see C is going to be your, C is actually give the y-intercept, as you know. So from here, actually from there itself, you will get 4a plus 2b is equal to, C is actually your 4 is equal to 4. Cancel out 4a plus 2b is equal to 0. From this equation and from these two equations, this is going to be 4. And you substitute, you need to solve that solve using these two. Okay.
Okay, sir. Okay.
Okay. So now let's start the revising thing. We have all SSC. I will try to skip because I told you the SSC thing. So let's start. The first is let's talk about the set theory. So okay. So what is set? Set is nothing but a collection of well-defined object. What do you mean that? So if you think, I want to, somebody says just collect, set is the collection of well-defined objects. So what do you mean by well-defined object means? Suppose you will say in a class you said that collect those student whose mind is very fast or who is very skilled or who is very, let's say very fast, whose mind is, or who are very wise. Okay, collect those students. So how we will that? Is wise word is a proper or well-defined word? Because every student in their own pace, in their own, is wise. He is having good mind. So that wise is not a proper word. Now, if you say the another word, collect those in a class, collect those.
Sir, we can't hear you.
Sir, your voice is mute.
Yeah,
Hello,
just
sir.
yeah, just a minute. I just muted. Just a minute.
Sir, we cannot.
Sir, we can't hear you.
Yeah, just a minute. Yeah, I just muted. I will be back. Okay, just a minute. Yeah. Let's continue. So, yeah, sorry for I just call important call. Okay. So, well-definedness word is, I hope you got. So, if in a class you have, if you say a vice student or
So your voice is
Sir, your
breaking.
voice is breaking.
vice student, so this vice word is not a well-defined word, and you will not able to collect a vice student, because each student in his space is a vice. Okay, is it clear now? Am I audible?
Yes, sir, you
Yes,
are
sir.
now.
Now it is better, sir.
Now it is better, no? Okay.
Yes, sir.
Okay. Okay. So well-defined means the same thing. If you say the wise student, so each student is in his own pace, he is wise. So well-defined, the wise word is not well-defined. If you say the collection of student whose height is more than 5 meters, or in between the 5 feet and 6 feet, so that is a well-defined word, and you are able to collect the student who has having height between 5 and 6 feet. So that's the mean here, well defined. So set is nothing but actually a collection. Let's say I am collecting some student name in a class: Rakesh, Mahesh. Okay, some name I just collected. So this is a collection. So set is nothing but a collection of object, but the object should be well defined. It is not a very it should be very clear that okay, you are collecting Rakesh Mohan, this student, or you are saying, or 5.6 meter height student you are collecting. So set is a bucket in which you are giving some well defined object. That's all. That is the set. So there are two kinds of notation you can present that. There is either you can list out the all collection, or you can form that is called set builder. Try to form the set that, let's say I'm saying collection of even number. Suppose yes is a collection of even number, even natural number. So if you collect all even natural number, so that would be 0, 2, 4, 6, like this. But this is not a best way. Like in the notation form, you need to write the all element. But where is the difficult to write the all element, like here, even natural number, then what you can do, you can make a set builder notation form. You can write that. So how you write that? So x, so you can write this way: x such that x is a natural number, and x modulo or x mod 2 is 0, or x is the multiple of x is a multiple of 2. Like this you can say the word. Now this is, there are two ways. So this is the same thing. X is a natural number and x is multiple of 2. So this is the one.
2, 4,
So
6, 8, 10.
Yeah, now it's came. Now if you think that it is if you elaborate this set, so the terms will come now: 2, 0, 2, 4, multiple of 2 will come. So this is called the, like you are explaining your you are writing If you are unable to write the each element, if you are unable to write that each element one by one, so just try to comprehend that. So this is called set comprehension also. You are comprehending the exact, and this is right side of vertical bar. This says that okay, you are collecting x which have this property. What is the property? X is a natural number and x is multiple of 2. This x have two property. This is the proper way to write a set. If the set is a collection of infinite number, you are unable to note collect. Let me mute. Somebody is having muted. Yeah. So this is called this. So this form writing a set in this fashion is called set comprehension. Okay. So now the next thing is, let me quickly go with one by one the content. What are the in weeks? Yeah. So in this, the first thing is a natural number, and the set theory is from here. So this is called a set. Try to make a set. A set is nothing but the collection of well-defined object. Yeah, somebody is want to say something? Fatima.
Sir, this is N group, sir.
Yeah.
So, can you also give me an example where the transformation that happens, sir, in the set comprehension, where the value is a comma b or something like that. So I have a little bit confusion over there. Your voice is breaking, sir.
Can you repeat again, please?
Sir,
What do you
your
mean by
voice is breaking.
transformation?
Sir, we in the set
Sorry.
comprehension, I
Is
want
it
to
clear?
know. Yes, sir. Now it is better. So in the same set comprehension, instead of x that is in the left corner near the
Yeah.
bracket, so if we put a comma b and there is a set of conditions in the right side. So can you please explain in that case, because I get confused if there is a two variable.
A comma B and some explanation on A and some explanation on B. Is this?
Yes, sir.
Okay. So on this, so that means this set have only two element, I think.
No, that's not what I meant. So a comma b and right side there should be some kind of conditions like we just had, right? X is a multiple of 2. So similarly, some conditions can be given for a comma b. But I want to understand like how when two variable is involves here. So how it actually works.
Okay, so by writing this way is, I'm not sure this is a proper way. This way you need to be write like this. A, and because in set comprehension we have only right side one and just explain that word. And another just take union, the second one B, collection of B, and write the explanation of B. This is the correct way. I don't think this is a correct way. This is not like just writing to your if you are writing in a pairwise, that's fine. A, B. Now you are giving, because this is an element.
So
See,
that
this
is what I
says
actually
only
meant,
two
sir.
elements.
The
Yeah.
communication gap was there, but that is what I meant actually.
Oh, so this is the okay. This is the mean. So this is a single pair, and you are giving some explanation on B, and you are giving some explanation on A and B on by. Now, like for example, let's say you are collecting some pairs. Okay, some pair. Let's say you are collecting some pair. Okay, let's say A B, where explanation on A is, let's say A is even natural number, and B is multiple of 3. Now, if you think the what is going to be the collections here, so it could be 0, 3, 0, 6. This will come. Okay, and the other element maybe 2, 3, 2, 6. Other element like this element will.
So it is the same, except we have it as a pair. That is the only difference. So if they put A comma B, which means there needs to be a condition for A and also a condition for B as well.
Yeah, yes, B as well. Yes.
Okay, sir. Got it, sir. Thank you, sir.
Sir,
Yeah.
sir, if two sets are given A and B, when say in a question exactly one means exactly one language and exactly one object, it is a symmetric difference, no?
Only one element. No,
Yes, sir, only one is exactly one.
symmetric difference. Only one element is there. No.
No, sir. I say
what are you saying? Symmetric. Yeah. Can you
sir,
repeat again, please? Yeah.
difference. Sir, when if two sets are given A and B,
Okay.
have elements and some elements are given, and
Yeah.
sir, the question says exactly one element exactly. Sir, exactly given means it is a symmetric difference. Now I can.
So what is the
understand you.
symmetric difference? So symmetric
Yes,
difference
sir.
is A minus B union B minus A. This is the symmetric difference. That is called. I
It
think
means that exactly one language are some areas are language question in this.
some area. No, I am not getting. The
sir,
symmetric difference
okay, sir,
between
okay.
two sets is, I think the notation is this one. For the symmetric difference, I think this one is. A notation is kind of this one. Or maybe let's say you are saying symmetric difference, no word. A between A and B symmetric difference, which is have this one, A minus B union B minus A. This is the symmetric difference between two sets.
Okay, sir.
Okay. Okay, so this is telling about the sets. I'm not going to talk about the real numbers. You already know the real number, natural numbers, integers. Yeah, rationals number have some, if you want to know the some property. So there is, rational number. So rational numbers means you are able to write a number in the P by Q form, where P or Q, as you can say, or co-prime to each other, and Q not equal to 0. So these two conditions, or you can say you are able to write the. Okay, what happened with the internet today? Am I audible? My voice is clear, right?
Yes, sir. Clear, sir.
Yes, sir. Yes, sir.
Yeah. Okay, so you are able to write in this fashion where Q not equal to 0. So those are called the rational numbers. Now, for example, is this pi is a rational number? Is rational number? This is the question. So rational means what is pi here? Pi is some value 2.7, I think, or 3. Some values are there. No, I think 3 point something. Some values are there. So rational and irrational means if you are rational means if you are able to write in the P by Q form, but irrational means only you are unable to write in the P by Q form. That means if you are able to write in the point form, where the point condition on this point means each terms will be not, the terms will after some time it will not repeat, like 1 4 7 8 9, after 8 it will be become 6 6 6 6 6. So in this case it is a rational number. So irrational numbers, if you will say, so those numbers, if you are writing, if it is in a point form, or if whatever the way it is, it will not repeating and not terminating is called the irrational number. Those are numbers are irrational number. If it is not repeating each time, it will be like it will be always 7 8. It will come 6 4. Now it will be continue. It will not repeat, and after some time it will not end. Okay, these points are called, these numbers, such numbers are called irrational number. So pi have such, E have such. This E is So E have something 2.7 some values, and it will 7.13. It will continue. It will not repeat after some time. It will always fluctuate or vary to infinite time. So those number you can say as the irrational number. Now let's move on to the natural number, rational number, irrational number, set comprehension we did. Now there are some operation on set. The second, the operations are like union. So let's say generally we denote the sets as the capital letter of this English thing, English character. So if you have suppose two sets A and B, so if you think about A union B, so this is called the collection of those elements which having both, like this will be a set first thing, and if you I will write in the set builder form, so it will be X such that X belongs to A or X belongs to B. This is the mean here, A union B. It means you are collecting all those elements which are in A also or in B also. That's all. And A intersection is B is collection of those elements which is in A and in B also. This is called intersection, which is in both sets. You are collecting those elements which are available in both sets. Now there is set difference. So this is a collection of those elements which is A but not in B. So that means, suppose for example, let me make it, let's say 3, 1, 2, 5. Let's say this is A and B is, let's say 3, 5. So A minus B will be, just remove those elements which is B. Just remove those elements from the set A which is in B. So that means 5, 3 and 5. Just remove that. So it would be 2 and 1 and 2. This is the set difference. Now say symmetry between two sets is, just now I give the definition, A union B, A minus B, sorry. This is A minus B, or this is called A minus B. You can write like this or this way. So, or this way, A minus B union B minus A. So this is the collection of those elements which is exactly in A and which is exactly in B. Not available in both. So you can remove the common element and just take that. It will be in the symmetry in between two sets. Now these are the set operations. Now there are relation. Now next is the relation. Relation is somewhat many times used to student got confused between the relation and function. So what do you mean by relation? So before to know the relation, there is a term Cartesian product. So Cartesian products means what? Suppose you have a set A and you have a set B. There is a definition on this, A cross B. What it mean that? Again, I will write in the set form. So how it will be? So this is a pairwise. This denotes a pairwise element. So in the set form, it will be like A and B. Such that now in the set builder form, I'm writing it A comma B, where A belongs to A and B belongs to B. This is the Cartesian product. So or means let's say A is equal to, let's say 1, 2, and B is 3, 5. So A cross B is equal to what? Collect those possible elements which come in pairwise first order. If it will come in the pairwise, where the first coordinate will be from A and second coordinate will be from B. So that means the element will be 1, 3. This is 1 is from A and 3 is from B. 1, 5 it could be, it may be. And so A cross B means you have to collect the all possible element which come as in the pairwise. Now 2, 3 and 2, 5. So if you see that, so there is one word, cardinality of a set. So cardinality of a set is nothing but just count the number of elements. So number of element is actually the cardinality of a set. Like for example, what is the cardinality for this case of the set A is? It have 2 elements. Cardinality of this set is 2. So notation of the cardinality is generally in between 2 vertical lines. You will give a set notation that is generally used to for the cardinality of a set. Am I audible?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Okay, please stop me where if you are not getting or if I am going very fast, okay?
No,
Because
sir.
yes,
You can proceed, sir. Very nice.
okay,
Yes, sir.
okay. So so this is the notation of the cardinality, and the Cartesian product is the all possible pairs you need to write. Now, if you see that the cardinality of set A is 2 and cardinality again the set of cardinality of the set B is 2 again. So if it, now there is the question will come in your mind that what is going to be the cardinality of the set A cross B. Now the cardinality of the set A cross B is just a product of cardinality of A and cardinality of B. So if you see that the same thing is happening here, if you see the Cartesian product here A between the set A and B, so if you count the number of elements, so this is a single pairwise element, this is a single element, this is another element, this is another element, and this one. If you see that this have 4 elements. So cardinality of A cross B is nothing but the cardinality of A and cardinality of B. So and actually this is a Cartesian product. So why we are studying? What is the purpose of study this such kind of Cartesian product? So there is one thing. Actually, the relation is nothing but a Cartesian product. Okay. What do you mean by the relation? A relation, let's say I'm defining a relation on a set. So defining a relation on a set means what? So you are defining a relation on a set means you are giving relation between the elements. So let's say what is the relation between elements mean to say? I am saying, let's say for example, let's say A is a collection of even numbers. Okay, that means 0, 2, 4. Okay, this will come. Now I am saying two numbers, two element are related if two numbers are related if, let's say, if A is related to B if A square is equal to B. That's the one thing. Two numbers are related if A square is equal to B. So what it means that, so I'm defining now. Now the process is you are defining a relation on the set A. The relation is you are defining a relation on set A. How the relation is? The relation is A is related to B. Now this is now you will write like a pairwise. A is related to B means A is related to B. You will write this is the relation in notation form. That means here A square is equal to B. Now what are the elements will come here in this relation, like 0, 0, right? If you do the 0 square of 0 will be 0. If you think 2 and 4, if you do the square of 2, you will get 4, right? 3, 9. 416, 525. Like this will come. Correct? So A is related to B means this R you removed R with the comma. And in the set builder form, it will look like this. Here, if you were use if A square is equal to B. So if you in the elaborate form, if you think that this is the elaborated form of this set. So that's the here. Now see that what is happening here. So if you see that this R is nothing but a subset of A cross A. See that? If you talk about A cross A, what would become here? You are taking the even natural number. So what is going to be A cross A? A cross A. You are taking the Cartesian product with same set. So that means it will come 0, 2, 0, 2, 0, 4, 0, 4, 0, 6. Okay. Some element with the 0 will be the first place. Now 2, 0, 2, 6, like this element will come, others element like this, the other element come. So A cross S is you are taking the Cartesian product with the same set. Now see that what is the R here is happening. R is actually a subset of A cross A. So now the terms, what is the relation between, what did the mean, why we are taking this Cartesian products? So Cartesian products is actually give a relation kind of. So any subset, now suppose I am taking, let's say A cross B, now taking another subset of, or let's say A from A itself, A cross A. I am taking another subset. Okay. So let's say I am now S is what S is actually 0, 2, and 4, 6. 4, 6, 8, 10. That's all. So actually, yes is a relation here, but we are unable to give the proper word to yes. But yes, yes is a relation in between the element where 0, 2, 4, and 6, and 8, 10. In between the element which are in set A. So relation is nothing but a subset of the Cartesian product. That's all the definition. If you take any subset of the Cartesian product, that represents a relation on the set A. Now, if you have a relation, so there are some types of relation. Symmetric relation, reflexive, transitive. These three main we have relation. So let's say I'm saying the reflexive relation. What do you mean by reflexive? So before to relation means you have already a relation and you want to check that is this relation is reflexive or not. So what do you mean reflexive? Reflexive means you are collecting, means this R, this relation should have, means each element, means whatever the, if you are saying R is a reflexive means on a set A, R is a reflexive relation on the set A. Let's say A is actually, let's say I am saying ABC. And you are saying R is a relation on set A, which is reflexive. That means each element is related to itself. Whatever, I don't know what is the relation. Let's say you are saying I'm defining a relation on a family member, or let's say A is a collection of a family members. I'm defining a relation on that set is A related to itself. How we will define? Two persons are related if they have both have hair. Let's say hair. Each person have hair itself, means hair on the head. Hair means hair on the head. So each person have the hair. Maybe some members don't have hair. They are, let's say, they're without the hair. Maybe on head, they remove all heads. They have shaved hair, their heads. So those family member will not come in a pair, right? So but you will say each person is related to itself. So here reflexive means if you are defining R is reflexive, that means surely this will happen. Maybe other element come, AC, no matter, but this should happen. Each element is related to itself. Then you will say R is a reflexive relation. The second is symmetric. Symmetric means what? Here is, let's say, am I audible? Because for me it's showing
Yes,
there
sir.
is an internet. Okay. So is it clear to all of you what I'm saying? Please just stop me if you are not getting.
It's perfectly all right, sir, as of now.
Okay. Okay, just a minute now. Now let's say you have a relation, let's say I'm saying R1, which have this property. Relation R1 on a set A, we are just now same set here, let's say A. So how the R1 is, let's say AB is there in that pair. Now the relation will be in the pairwise. Okay. AB and let's say BA is there. And let's say BB is there. That's all. So reflexive says if A is here is, if you write this one is what I said, A, if you write in this form, so you change this R with the comma, and this way you can write. So each element can be written as this way also. A related to B, B related to A, B related to B. This is the mean. Or this R is actually changed in the comma. That's the mean here. B, B. So here is, this means says A is related to B. So reflexive says if A is related, sorry, symmetric says if A is related to B, then B should be also related to A. Means if you change the order. So here is B related to A also. So in the Cartesian product, I just now said orders matter here in the pair. This is the first coordinate, you can say this is the second coordinate. So here the pairs order of the pair will matters here. This says A is related to B and this says B is related to A. So for example, let's say in a family collection of, again, if you are taking a member of a family, and I will say two members are related to each other if they are brother. Now, if A is brother of B, so B is brother of A also. So that relation is now is going to be a symmetric relation as here. So A is related to B, B is also related to A. This is the mean to say symmetric. Now the next one is the transitive. Let's say I'm taking a relation R2 which have this property. Let's say AB, A is related to B, BC, B and C related here. This implies and AC. AC is also related. Some other elements also. Let's say B is there. So B, okay, fine. Yeah. So see that if A is related to B, B is related to C. This implies, see, you are getting the next element is A is related to C. So if you have these two things, this implies the next A is related to C. If this property, relation have this property, then you will say that relation is a transitive relation. For example, if you again say in a family member, okay, collection of family member, if two persons are brother related to each other, if they are brother. So if this member is brother of this member, and this member is brother of this member, so it is clear that this member is brother of this one also, right? That brother relation is actually a transitive relation. That's the mean to say that transitive relation. Okay, so these are the relation. Yeah.
Sir, 2, 2 is a transitive, no?
2, 2.
It's a relation. 2, 2 is a transitive.
On set, let's say 1, 2, 3. This one on a set, which is the collection of 1, 2, 3.
Yes, sir.
On this relation, yeah. Okay, if you have a relation R on a set A, let's say A is this one. So this relation is transitive, because it's meant to say each reflexive relation is actually a transitive relation. Means there is no element, no, talking about the condition is important. Suppose the case is this element is not here. A is related to B is related to C, and only this element is given B now. So actually this relation is not transitive. As says A is related to B is related to C. This implies A is related to, means A comma C should be in that set, but here is not. So this relation is not transitive. And for reflex, if you talk about now, let's say this is the relation you have. So B is related to B, and if you have, suppose this one is there, 2 and 3. Okay, this implies, so if you have this one, so this is a transitive relation. Why? Because 2 is related to 2. Okay, 2 is related to 3. This implies 2 is related to, this is a one thing. 2 is related to 2. 2 is related to 3. This implies 2 is related to 3. Again, you will get the same element as you are getting. So actually, this is a transitive relation. So mean to say the reflexive relations are actually transitive relations, because there is no itself they are related. So this all about the reflexive, symmetric, and transitive. Now let's move on to the function. Function is nothing but a relation. We are generally used to say function is, we generally used to denote, let's say fx is equal to x plus 5. Yeah, this is a function. Actually, this is a function.
Sir, what about anti-reflection?
If you know the notation of, yeah. Oh.
Sir, what about
anti-symmetric?
is,
oh, sir, have taught anti-symmetric also. Okay. Anti-symmetric. So, okay, I think I'm missing that. Okay. So I thought, okay, reflexive, symmetric, and transitive there. Okay. If there, yeah, okay, there if sir have taught anti-symmetric also. Okay. A relation is said to be anti-symmetric. Okay. Just a definite is there. A relation, let's say R3 is there, a relation on a set A. Okay, on a set A again. On a set A is said to be a anti-symmetric if A is related to B. If let's say A is related to B and B is related to A, these two pairs are there. This implies A equal to B. For example, I am saying, let's say I am, let's say A is actually the collection of natural number. Okay. I am defining a relation on the natural number is that, let's say a natural number which does not contain 0. Okay, I'm just remove the 0 element. Okay, so I'm defining a relation on this set is let's say a number is related to another number, okay, which divide, let's say, I am defining a relation on this set is A is related to B if A divides B. That first one divides the second one. Okay. This is the relation here. That means if you think R contains actually, I just removed 0, no? So A is a collection of natural number which does not contain 0. So let's say as now the relation contains 2, 4. A divides B, correct. 2, 4, 2, 6. Okay. And let's say 2, 8. So these numbers, rest of the numbers will come. Now this relation is actually anti-symmetric relation. Check that how it is. Let's say now, if A is related to B, fine. 2 is related to 4. Is that 4 is related to 2? No. 4 cannot divide 2. Suppose there is a case A is related to B means A divides B. And B is related to A. Again, that's another condition. B is related to A. That means B divides A. This both implies A equal to B. Now, if you think about it, this relation contain 2, 2 also, right? Because 2 divides 2 and this A divides B, B divides A also. 2 divides 2 and this 2 divides 2 also. And this says A2 equal to 2. So that's why 2, 2 pair will contain this R. Containing this R contains 2, 2 also, 3, 3 also, 4, 4 also. Because whenever such conditions are there, A related to B related to A, this implies A equal to B. So actually this divides relation is an anti-symmetric relation. Clear? This such kind of relation called anti-symmetric relation.
So anti-symmetric and asymmetric, are they similar or different term?
Asymmetric is totally different. Asymmetric says if A related to B, then B never be related to A. This in a relation, if you are saying that this relation contain the pair A comma B, then this relation will never contain B comma A. It will never contain. Okay, and not even A comma A also. Such kind of relation, if it is containing, then it will never be asymmetric. So that's the meaning here. So actually we will say in the pictorial form, suppose you have see, Cartesian product is actually let's say this is A, this is B. So these are the points is actually the Cartesian product point. So if you are changed with the A itself, so this is the A, these are the points. So symmetric relation is actually contained this one. Let's say this is the diagonal. So these elements, it will collect these elements A comma B and equal to also. But asymmetric is only contains without the line, only A related to B. It will never, this part will not come, this part be related to, or not even the diagonal element also. That means here, if R is saying to be asymmetric, that means A comma B pair will be only. It will never contain B comma A or A comma A also. See that A B comma A means this portion or A comma A means this line. It will never contain such. So those are called asymmetric relation. So sir, I have not taught asymmetric, only just talk about the anti-symmetric. So no need to worry about this. This relation will come in the exam. Okay. Only till asymmetric may come. Sorry, anti-symmetric may come.
Okay.
So let's move on the function. So as you know, the function generally in our case is, let's say a function is x is equal to 5. So actually this function is a relation itself. See that how it is happening. If you see that this function is actually this f is actually a subset of R cross R, where R is for the domain and the second R is for the codomain. So if you collect this one as a pairwise, what it will come? If you substitute s is equal to x is equal to 0, you will 5. X is equal to 1, you will collect 6. X is equal to 2, you will collect 7. See that what is happening. So f is actually the collection of points and collection of points. So f is actually a subset of R plus R. So actually functions are nothing but a relation, but it have two properties. Two specific thing it have. It contains two essential thing. What is this have? Means, so any relation can be any function is a relation, but not all relation is a function. So function is a relation, but it have you need to constraint on the relation. So what are the constraints on there? So this means, let's say you are considering a relation such that 0, 5 and 0, 6 and rest are the some element have. What it means that you are giving here for 2, you see that the first coordinate had the same, the second coordinate is different. So, but this will not happen the case for function. It is not happening the case. So see that what is one thing also. So you are wrote here in this fashion, this function is in this fashion is written here. So this is actually input and this is output, right? The second coordinate is output. Now you can think the relation. In the relation is actually A cross B, right? A relation is actually subset of A cross B. Any relation is subset of A cross B, or if it is on the same set, so subset of A cross A. So this set is called input set and this set is called output set. So as here in the function. So the first coordinate it actually tells you the inputs and the second coordinate tells you the output. So if in a relation, if you have two same input but two different output, here is the see that this is happening. For the same input 0, 0, 0, sorry, for 0 same input, you are getting two different output. This will not case happen for the function. It should not happen in the case of function. It will never happen for the case function. Okay. This is one condition on the relation, and the another condition is each element have output. So suppose I am writing the case here. Let's say f is equal to, I am defining a relation on a set A where A is actually 1, 2, 3. Okay, I'm this relation is such kind of 1, 2. This is subset of A cross A. This is a relation of, okay, on a set A. So this is subset of A cross A. Let's say 1, 2, 2, 3. That's all. So this is input, this is output. This is input, this is output. So for the first input 1, you are getting output 2. For input 2, let's say you are getting output 3. But what about the third input? You are not giving the third input, this one. You cannot leave the any element from the input set. So that means this relation is not a function. So for whatever, this is called the domain. So for each element there should be output. You cannot neglect and even single element. So this there should be 3, some have. Okay. So 3, some have. For each element of the input, there should be output. These two conditions for the relation. If a relation satisfying these two conditions, then that relation is actually a function. Okay, this is all about a function. In notation form, it will be like I'm defining a relation on set A. I'm defining a function on a relation on the set. This is A cross B. So this is input, this is output. So let's say this is A, B, C, and this is 1, 2, 3. Okay. So the first condition said it will be never the case like this. That means you are getting for two same output, you are getting two different output. So this is not a function. Again, if it is happening 1, 2, 3, sorry, A, B, C, A, B, C, 1, 2, 3. This is A, this is B. So if you are suppose this is happening, that's all. That means you have A comma 1 and B comma 3 in F. You are not getting the output for C. It may be some element can remain for output, but for input, no should each element should have image. So you cannot. It could be the case here for the function. This is correct. This is a function, but this will, if it is not the case here like this, then this is not a function. Okay. This is all about a function. Now you have two types of function. 1, 1 and 1, 2. So 1, 1 means a function said to be 1, 1 if for each input you have output. So the case is for 1, 1, a function is said to be 1, 1. This case should happen. Let's say A, B, C, 1, 2, 3. Let's say 4 here is also. Okay, so this is happening. Okay, for each output, you have a unique input. Whatever the output you are getting, it have a unique input. It could not have like this also. So suppose this function is 1, 1. Actually, this case is happening. Let's say A, B, C, and 1, 2, 3, 4. So let's say this one. Okay, this one. So see that for this output, you are getting two different input, A and B. So this is a function, correct? This is a function, fine, but not 1, 1. Not 1, 1 function. Okay, this is the mean to say 1, 1. And for definition, mathematical definition, that is writing the best way is, suppose the best way is write to, let's say, a function from set A to B you have given. So definition, let's say A, B belongs to the domain, okay, such that f of A is equal to f of B. This implies A equal to B. If this condition follows by this function, then you will say your function is 1, 1. This is the mathematical definition. And
so what's it the other way?
The other way is actually for the well-defined, and other way is actually checking for the is this relation is a function or not.
Yeah. Suppose if one input provides two outputs, then it's still not 1, 1, right?
Inputs provide two outputs. One is single input provides two output. One single inputs provide two outputs, you are saying. So in that case, your function not that relation that whatever the relation is given, not on a function. Yeah. Not function. Okay. So before to 1, 1, you need to check first, is this relation is a function or not? Then you need to check, is that function is 1, 1 or not?
Okay, sir.
So I'm looking to raised hand. So yeah, Fatima, sorry. Fatima, yes. And
Oh, I
Ah,
had raised this hand when you were clearing doubts, but now you're doing
okay.
revision. Can I ask
Okay.
my doubts now?
Yeah, related to whatever we discussed.
It's one of the activity questions.
Then I will say just skip for the last.
Uh,
Because let's say
I
continue.
would appreciate
Let
it
me
if you
continue
could do
with
it
the
now.
revision. Let me continue with the relation. Then we can discuss the doubts in last.
Okay, and till
That's
when will this
why
session?
I took in
Sir, your voice is breaking.
starting. Yeah, once it will be finished, I don't know. I will try to. Okay, let me check it once. Is it
Sir, your
clear now?
voice is breaking.
Is it now? Okay. Is it clear now?
Yes, sir.
Yes,
Yeah,
sir.
maybe. Now, my side is raining actually. So because of that, it may.
Yeah,
Yes.
once in a while, your voice gets dragged, so it's quite difficult to understand. But now it's fine.
Okay. Okay. So this is saying to be the 1-1. Now one thing is on onto. So there is one another thing is a function is said to be onto. So a function is maybe 1-1. But yeah, there is one another type of function that is called onto. A function is, let's say you have a function a to b. A function is said to be onto means for each. Okay, let me in the pictorial form to represent. Let's say this case is there. Let's say you have a function. You have two sets a cross b. Okay, that means a to b. Okay, there are many ways to denote it. A to b like this or a cross b. So let's say this is a, b, and c, and let's say this is 1, 2, 3, and 4. Okay, so suppose I'm this a goes to 2, b goes to 1, c goes to 4, and okay, this is the case. So see that b contains some element, a contains some element. So see that for 4 you have a 3, for b, for 1 you have b, for 2 you have a, so 1 have me means, let me see word with the pre-image thing. So 4, so pre-image means this is an image, this is a collection of image, means to say output. So for this output you have a input. Okay, for this output, this you have an input. But what about the 3? 3 is written in the output set, but it don't have input. That in other word, 3 is an image, it don't have pre-image. In this case, your function is not onto. So in a word, for each element or for each image, it should have a pre-image. Then you will say that function is onto. For each image. So see that for each image, for 3 there is no pre-image. If you remove 3 here, now the case is have a pre-image 3c. So sorry, for each image, but the case is here 2 and 3 is there, and 2 and 3 is there. So in this case, for 3 is in the image set, but it don't have pre-image. In this case, your function is not onto. Okay. So the for onto case, that is onto is there is no proper mathematical way writing by this way. The best word is for each image it should have pre-image, then that function is actually onto. That's the definition. Okay. Okay. So this is the for 1-1 onto. That's all about the week 1. I think it's covered. Now let's move to week 2.
Sir,
Yeah.
So in the on to example, you have done one example, no, sir?
Yeah, this one.
Yeah. If we add on, if C tends to 3 means, including that conditions, it will be on to or not, sir?
If C tends to 3 also,
Yeah.
this is the case. So in this case, this is not a function even. This is not a function because you have to input, you are getting to different output.
Okay.
So if the relation is not a function, then there is no mean to talk about onto itself. In this case, you can cancel out. So don't talk about now here the onto. Whenever you have a function, then you will talk about the onto case.
Okay.
Okay.
So another one doubt, sir. If in left side we have a AB and CD.
Okay, D. Yeah.
And in right side we have 1, 2, 3, sir. Sir?
Hello, sir. Hello.
I think he has some network issue and the call got cut. Let's wait case, I think.
Am I audible right now? I got disconnected.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So suppose the case is this one. Okay, this one, or let's say 3, 1, 2, 3, and this one. Let's say this one, 1, 2, 3. Okay, and this is the case here. So for D, yeah, it's fine. This is a function. So see that for each element, it should have, for each image, it should have it have a pre-image. Yeah, for 1, it have pre-image B. For 2, it have 2 pre-images, A and D. But yeah, our definition said it have at least 1 pre-image, or it's have a pre-image, or pre-image. What is there? Or what is there? So yeah, it have 2 pre-images, but yeah, at least it have 1. So yeah, that's fine. And for 3, it have C as a pre-image. So actually, this is a function, and this function is actually onto. Okay.
Okay, sir.
Now let's move to on the straight line. We'll quickly recall because
Sir.
yes.
Yes, sir. Any formula for identifying function is onto or
No. So yeah, that's I said there is no algebraic way to say this is by like the for 1, there is not a proper way. You have each time you have to guess, or not guess means you have to properly analyze the
give me
function.
some examples, sir, like any expression? Like
Sorry.
Sir, can you give me some examples, sir?
Yeah, so for example, let me give a, let's say fx is equal to, let's say x square plus 3x. Let's say this is this is the function we have. So is this function is onto, or is this function is one word? So how we'll check this? So this function, let's say this function is from R to R. This function is given R to R, which defined as this way. Okay, this is the function. The whole function is given like this. Is this function 1, is this function R2? You need to check it. So how we'll check it? So that's the process. For 1 we have one this way. So let's do that. Yeah.
Sir, so number of subset, how can find in relation?
Number of
subsets.
Number of subset is, yeah, there is, if you have but n element in a set or cardinality of a set n, so there is a formula, 2 power n is the collection of number of subsets for a set n A.
Okay, sir.
Yeah. So how we will check that is this function is 1 1 or is this function is 1 1 or not? So let's check this. Is this given function is 1 1? So if you go with the definition we are by this way, okay, let's do that and we'll see that are we getting or not. So let's say A and B belongs to the domain, this R, such that f of A is equal to f of B. That means this says A square plus 3A is equal to B square plus 3B. That means now let's solve it. A square minus B square plus 3A minus 3B is equal to 0. That means it would be A plus B, A minus B plus, let's say 3 common, A minus B is equal to 0. Now here is A minus B, let's take common. So A plus B plus 3 is equal to, plus 3 is equal to 0. So am I audible right now? Am I audible?
Yes,
Yes,
sir.
sir.
Now you are audible, sir.
I got disconnected. Why? I don't know.
Sir, I think you
Okay.
can reduce
So
the
till here, is
video
it clear?
quality,
I
sir.
just solved that. Okay, let me change the. Is it clear now? Am I audible?
Yes,
Yes,
I
sir.
think it
Yes,
will
sir.
now, it will not interrupt. Okay. So is it clear till here?
Yes,
Is
sir.
it clear? Okay. Now see that this first coordinate says A equal to B. You have f of A is equal to f of B, where A equal to B. But there is another factor. A plus B is equal to 3, it may be. A plus 3 is equal to 0 also. This is the problem here now. So that means if you choose, let's say A is equal to 1 and B is equal to 3. Oh, okay. Sorry. B is equal to, now here, if you substitute here A is equal to 1. If you substitute B, then what would be 1 plus, sorry. It is 1 plus B plus 3 is equal to 0. That means B is equal to minus 4. So if you see that what is happening here, if you choose, whatever the value x is equal to 1, it have same value x is equal to minus 4 also. So you can check it. 1 is equal to, at x is equal to 1, the value f1 is equal to, I think 4, right? If you substitute x is equal to minus 4, that means f minus 4, what it will be? This is 16 minus 12, which is 4 again. So see that what is happening. Two different input, you are getting same output.
Yes, sir.
So this is not a 1-1 function. So one by one, by this procedure, you got that, okay, this is not a 1-1 function.
Yes, sir.
Now let's check for onto. Is this onto? So how we'll check it? So for this, you have to take some points. So you have to analyze now the function. You have to analyze your what are the outputs you are getting. So see that what are the outputs you are getting. If you see that this is going to be your x square plus 3x. So let's say here, let me write here, if x is equal to x square plus 3x you have. So this is, it will have 0. Okay. It have some minus value is equal to 1. For what value of it would be 1? So let's solve this for x. So now you have a quadratic equation. If you solve it here, for x is equal to real value, it give 1. I don't think it will give 1. No, you will never get 1, I think. Let's say, okay, let me check it. B square minus 4ac should be greater or equal to 0 for real root. So that means, okay, let's see it here. B square is, okay, it have real root. B is square is equal to 9 and minus 4, 1, minus 1. Yeah, actually it is greater than 0. Okay, so check it for, is this, let's say I am writing here, let's say A. Let's say alpha, I'm writing here alpha. So that means here 9 square minus 4 alpha should be greater or equal to 0. 9 minus here. So if you substitute here, alpha is equal to, let's say 3. So for 3, if suppose here is 3, for 3 you are getting input. I don't think now it have real root, no, because as b square, now b square minus 4ac, it will become here 3. So that here is
Sir, your voice is not clear, sir.
Sir, your voice is breaking, sir. Hello, hello.
Hello.
am I audible right now?
Yes,
Yes,
sir.
sir.
Yes, sir. Now.
Now, okay, sir.
I don't know what happened. The internet. My side is actually raining, because of that it may. Okay. See that? Okay, let's back to our current discussion. So see, for 3 as a output, you are not able to get now here input, because you will never get 3 as for value. There is no real root for it. This one, you are unable to get exactly x. So for such that your output is going to be 3. So in that case, your function is not on 2. Is it clear? So this is the process. Actually, you have to take from this output. You have to guess. You have to take some number, and you have to try to get that. Okay, for this number, do you have the input? If it is there, then fine. If it is not, then you will say no. That function is not on 2. Clear?
Yes.
Am I audible? Okay.
Yes.
So let's move on to we'll quickly now this week 1 contains more concept. Now week 2 and week 3 is not much having. In
So can
polynomial
we
is,
week 4 first?
yeah, we'll quickly let's one by one, let's do that. Week 2 is just a formula. Week 2 is just collection of formula. Straight line, parallel lines, distance between 2 points, distance between point and line, distance between 2 parallel lines. That's all, these 4 things. So,
Excuse me, sir.
yeah.
Sir, polynomial will be asked in quiz 2 or not?
Quiz 2.
Yes, sir.
Quiz 2 is, yeah, it may not, because Quiz 2 is actually more focused on 5 to 8, no?
Yes, sir.
So there may be not direct question, maybe it use the concept, such kind of. It uses the concept of polynomial, but yeah, you may not find the exact polynomial question. That's the thing.
Okay.
So let's move on to the coordinate system. So second is actually the coordinate system. So coordinate means here is you will be in a xy plane where x is and this y. So actually this x is a real line and this is a real line, another real line. Okay, the same real line vertically you just wrote. So this is actually representation. Okay, so these are the points there. So actually coordinate system is nothing but the r cross r. The one is for the vertical line, the another r is for the one r is for horizontal line and another r is for vertical line. That's the mean here. So coordinate system is nothing but the r cross r. Now these are the points in this. This is the representation and these are the points. Now if you have 2 points, let's say this is the points you have. So how you will find the distance between these 2 points? So let's say this is x1, y1, this is x2, y2. So this is just a formula for finding the distance between. Sir have already keep the proper proof in the video. We are not going to discuss. We just quickly recall because this is just a revision. So just quickly recall the formula. The formula is just take the differences between the first coordinate, square them, take the differences between the second coordinate, square them and just add. Okay, now this is one thing. Now suppose if you are able to collect all points which lie in a line. Line means you are able to collect such points which is in this fashion. So if you collect all those points actually represent a line. So how we'll get this? Can we relate in this a variable kind of thing? That's called the equation of a line. So generally a general equation of a line is ax plus by plus c is equal to, let's say, d. This is general equation of a line. So there are 4 different methods to write an equation. So the first equation, if you represent this line, this is a general equation of a line. Okay. If you are able to write this equation as y is equal to mx plus c. So whenever you have a line, so there is an angle, see that there is an angle. This lines form an angle with the x-axis. So let's say this angle is alpha. So this is, you can say this is a tilde. This is tilde on the axis line. So so there is one word slope. So if you take the tan value of this alpha, that is called the slope of a line. Okay. This is a slope of a line. Or this way, or suppose you have able to find 2 points from the line. Let's say this is x1, y1, and this is x2, y2. So if you want to find the slope of a line, so there is directly a formula. If you're able to have an angle, that's fine. Or you can use this formula y2 minus y upon x2 minus x1 to get the slope of the line. This will give the slope of a line itself. This tan alpha value, directly tan alpha value. If you have a 2 point, if you are able to get the point from the line, just use this formula, you will directly get the tan alpha value. That means slope of the line. So this m is nothing but the slope of a line. Slope of this line. And c is actually the y-intercept, this distance on the whatever this intersecting with the y-axis. This called the slope intercept form.
So if alpha is given, then we we can use tan alpha. If alpha is not
Yeah,
given, then we
tan.
can
Use this one. Yes. This form of line is called slope intercept form. Another form is called the intercept form, which is, let's say, x by a plus y by b is equal to c. This is actually nothing but this fashion. This a is actually x intercept. Sorry, this a is actually x intercept. This is x-axis. This is y-axis. So this distance is actually a, and this distance is actually b. And I think sorry, I'm missing here. This is one here. Ax by a plus y by is equal to 1. This is called the slope intercept form. Sorry, intercept form. Okay. And yeah, these two forms are there. This is the general form. Okay. Now there is, now if you have, now you are in xy plane. Okay. So there are many infinite lines are there. Okay. There are infinitely lines are there. So suppose you have two lines, this one and this one. So, okay, so these two lines, let's say this represent, this equation of this line is y is equal to m1x plus c1. And for this line, you have y is equal to m2x plus c2. That means this line have slope m1 and this line have slope m2. Y-intercept on this line is actually c1 and this for this line have c2. Okay. Now two lines, is these two lines are parallel to each other? Parallel means they will never intersect. So how we'll get that? Only the slopes, even slope of the line can tell is these two lines are parallel or not. So suppose you have a equation of line this one and this one. So if this condition is happening, then you will say these two lines are parallel. Okay. So either these two lines are parallel or they can, suppose they are parallel or they are intersecting. Suppose they are intersecting in a vertical form. They are intersecting in the, let's say one line is here and another line is this one. They are intersecting and they are making an angle 90 degrees. That means they are perpendicularly intersecting. So how we'll get that? Suppose on the same line here saying, and they are not parallel, they are perpendicularly intersecting. So in that case, their slopes, multiplication of the slope is going to be minus 1. This is for perpendicular. And this is for parallel. This is the condition on the slope of line. There's no condition, if you see that there is no condition on C. This is just condition on M. And M is actually nothing but a slope of the line. So their slopes, if their slopes are equal, then you will say the lines are parallel. Their multiplication of the slope is minus 1. Then you will say those lines are perpendicular. Now, next thing is, if you have a line, suppose you have a line, this one, and this is a point. Okay, let's say this line is x1, y1. So this point is x1, y1. And this line is y is equal to mx plus c. Let's say I'm just writing in the slope intercept form. The best way is generally, I used to be use general. I used to many times use the line is just change. If I have any general line, I will change in the slope intercept form and use them, because slope intercept form is mean directly you give the slope and this will give the intercept y-intercept. And it is easy to use also. So suppose you have a point and this is a line. So is there, you can find the distance. Yeah.
The value of
Yeah.
C is the point where this line crossed the y-axis.
Y-axis, yes. Now, if you have a point here and a line, so can we find the distance between this point and this line? Yes. So there is a formula directly, sir have given the derivation of the formula. That formula is actually distance between a line and a point is nothing but I think, what is that? if you have in general form, let's say this not in intercept form, let's say I have a general case, general form of a line, ax plus b plus ax plus by plus c is equal to 0. I made a mistake here, I think. Here is not 0, here is 0. Not d, here is 0. Already I have used 3 variable ax, a, b, and 3 parameter a, b, and c. Here is 0. So this is a general equation of a line. Okay. Now distance between a point and line is, I think, ax1 plus by1 plus c upon root over a square plus b square. This is a formula. Distance between point and a line. And now next is, if lines are not intersecting, that means they are parallel, then there may be a distance in between these 2 points. So distance between 2 parallel lines. So let's say this is equation is ax plus by plus c, and this is, let's say this is a1, b1, and c1, and this equation is a2x plus b2y plus c2 is equal to 0 is equal to 0. So the distance between these 2 parallel lines is just find the mod value of the intercepts and this one, I think. This is the formula.
Sir, coefficients are same in parallel line.
Yeah. So I'm not making a mistake. Parallel, I just said, so this will be the same. So this A1, B1 will be the same, only the C1 and C2 will be different. Okay. So this is going to be the formula between the distance between 2 parallel lines. This is the distance between point and line. And these are the condition on the slope, then they will parallel and perpendicular. And these are the forms of the line. And this is the distance between 2 points. This is all about in week 2, only just formulas. Week 2 contains just formulas, so you have to remember this.
Sir, angle of reflection.
Now let's, sorry?
Angle of reflection, sir.
So angle of reflection is just a special case of not forms are particularly talked. This is just a special case of the perpendicular lines. So let's say this is, and this is the case here. Reflected with the making an angle 90 degree. This is the line, this is the line, they are perpendicular to each other. Maybe then there is some cases also, maybe not 90 degree. So surely some extra condition is given. Is this intersecting at this point, the point will be given. It's reflecting at this point. Using that, you will just find the slope of this one and point as this one. Maybe some extra condition is given. Using that, you will find the slope of this line, and this point is given. Use that, you can find the equation of this line. So surely some more things are given. So at least 2 conditions surely will be given. So that using those conditions, you can get the separately equation of lines. Okay.
Okay, sir.
This is just a special case of solving the equation of a line. Okay, so this is in week 2, and in week 3, in starting, we even discussing the quadratic thing. We just now studied about the function. The week 3 actually the quadratic function. Week 3 contains quadratic function. Quadratic function means what? This is the case. If you have a function in this fashion where a is not equal to 0, such kind of function is called quadratic function. That's all the definition of a quadratic function. That means it is a polynomial which have degree 2. Quadratic is nothing but a polynomial which have degree 2. So this is the quadratic function. So it has some properties. So the graph of the quadratic is nothing but it will be look like this one. It is kind of parabola. It could be this one. Either it could be this one or this one. If it is this, if it is x-axis and this is y-axis. Okay. It could be open upward or it could be open in downward. So if you see that this quadratic have one property that it will be symmetric about a line. What do you mean by symmetric about a line? That means if you see that whatever this points, if you compare with this one, okay, if you put a mirror here and this side, whatever you are getting, no, so this line is actually work as a mirror kind of. So whatever you are getting this side curve, if you take the image of it, you will actually find the. So quadratic graph of quadratic is nothing but a, there's a line that is called axis of symmetric. On this line, if you substitute, if you put a mirror, it will exactly symmetric. Whatever this side is there, it will be look like the same this side. So how we'll get this line? So there is a formula that is called axis of symmetry. So you have this quadratic function. So axis of symmetry is, what will be a vertical line, because as you know, each parabola will be either it will be open upward or downward. So axis of symmetry is nothing but a minus b by 2a. This is the line. What if whatever the quadratic is given, just substitute in this fashion. This is the axis of symmetry. This point where is this axis of symmetry and this curve intersect is generally called vertex. At this point, the function have either minimum value or it have maximum value. So for if it is open upward, so it have minimum value. If it is open downward, it have maximum value on the axis of symmetry. As you can see, the maximum value is here only. Rest are all the less than 0 value. And this is the minimum value and rest are the greater values. So axis of symmetry is there, vertex is there, maximum and minimum value is there. Yeah, there is one way to factorize, or now the roots how will. Root mean to say how where they're intersecting to the x-axis. See that these points or these points. These are all the roots of the quadratic where they are intersecting. See that at this point the value of the function is 0. See that this is the y line. At this is the point value 0. So at where the function value is 0, that is
only on the x-axis.
Only on the x-axis. So these points are called the roots. Where the root, how we'll find the roots where the function value is 0? That is called the roots. How we'll get that? So there are two ways. There are two formulas. Formula mean to say square method. There are 2-3 more methods. One is doing the factorizing the quadratic. Means anyhow we'll try to convert that quadratic in the x minus some alpha, x minus some beta, and using that you will say the roots are alpha and beta. Or you can use one, the best way is square method, or directly there is one formula itself that if you want to find the root of the quadratic is just do this one. 1, 2 for any general case. This is a general case. This is a quadratic. If you want to find the root of it, just substitute here. This is all about in week 3. I think. Let me see it. I think I'm not missing anything. Yeah, quadratic. That is called quadratic formula. Whatever I just wrote. This is square method is using the square method is actually the quadratic formula is actually generated by the square method. So you can see that is easy mean to say you easily understand. This formula is actually got from square method. So just see the derivation. If you want to see the derivation, just see the video. Otherwise, This formula is actually called the quadratic formula. So this lecture contains derivation of this one. And quadratic using factorizing it. So how we'll factorize? Let me give an example now. So as just now said, this is the factorizing. So how I will get this? Let's say I am giving x square minus 3x plus, let's say 4 is here. Or let's say 5 is here. You have quadratic, suppose this one, quadratic function. So how we'll get the root of this quadratic? So either you can use this one, or let's factorize this. How we will factorize? So this term is actually give the factors. Try to give the factors. So let's say 6, and we can write 6 as 6 cross 1. That means this will help you. And this sign says you have minus. That means you anyhow, if you subtract 6 minus 1, you will get 5. This is the 5 here. That means you can do this 5 can be written as 6x plus x. That means, or in another way, this 5 can be written as 6 minus 1, x minus 6. It means this is x square minus 6x plus x minus 6. Now this is x. You can take common from these two. This is x minus 6. Now you can take 1 as a common. This is x minus 6. Now we have two separate terms. So from two separate terms, you can take my x minus 6 as a common. So this is going to be x plus 1. By this way, this is the method to find the roots is factorizing the quadratic function. Is it clear? Am I audible?
Yes, sir. Yes.
Okay. This is all about in week 3, parabola and solving using the solution of quadratic in using graph, slope of quadratic. One thing I just missed. Slope of quadratic. So whenever you have a function fx is equal to ax square plus bx plus quadratic function. So see the derivative, there is a slope of quadratic. That is a formula, which is nothing but a 2ax plus b. This is the slope of the quadratic. What do you mean by slope of the quadratic means? Suppose you have a quadratic function, this one, okay? And what do you mean by the slope of the quadratic means? Suppose here is, let's say here you want to find the slope of the quadratic at this point, okay, at this point. That means slope of the quadratic means if you draw the tangent line at this point, slope of this line is nothing but can get using this formula. That's the mean of slope of a quadratic.
What is that formula, sir? 2ax plus b, right?
Plus b, yeah. Now the last thing is, now we are going to jump in a last week, that is called polynomial. What do you mean by polynomial? Polynomial is the kind of polynomial function which is written in this fashion. Let's say ax to the power n. Let's say any function in this form is written. A function in this fashion. A function is written in this fashion. Yeah.
Many monomial
Screen
contains a
shown you.
polynomial.
Screen doesn't show.
Is it for all of you or for me? For you only? I don't know. My screen is visible to all of you.
Yes, sir. Yes, sir. It's clearly.
Maybe for him only. I think he having some internet issue because of that. So let's say this is a0. So such kind of function is called polynomial. For example, let's say fx is equal to 3x 5 plus 2x square plus x plus 1. This is a polynomial which have degree. So degree of the highest term, this is a term of a polynomial. This is another term of a polynomial. This is another. So highest degree of the term is called the degree of the polynomial. So if you see that this term have degree 5. Okay. This term have degree 5. Then this is the degree of the polynomial also. This polynomial is of degree 5. So what is the use of this word degree of the polynomial? So this says it have 5 roots. At least it have 5 roots. Mean to say 5 roots. It may be complex or real. Okay, no issues. But degree gives you that it have, suppose somebody says it have 6 roots, so it cannot. So that means it have at least not at most 5 roots. That's the meaning of here. It can have lesser than 5 roots, less than number of roots, less than 5, but it will not go beyond the 5. That's the mean of why it is, what is the use of the degree of polynomial. So degree of a polynomial is nothing but the highest degree of the term. And what is the use of degree is degree of the polynomial is it gives the number of at most roots. Okay. So suppose if you are able to draw this graph, that means it have 5 roots. Let's assume that somebody is drawing like this. Says this is the graph of a polynomial. You will directly say no, because it have at most 5 root. But here in the graph, you are saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are giving 10 roots, but it have at most 5 root. So it will never be the graph of this polynomial. Okay. This is the use of, you can say, the degree of a polynomial. Now, if I have a polynomial, so there are many ways. So suppose okay. Okay. Now suppose you have a 2 polynomial fx and gx. So there is a way you can divide the polynomial also. You can divide fx by gx. So let's say you have fx is equal to let's say fx is equal to x cube plus 5x plus 1 and gx is equal to, let's say, x plus 1. I want to divide fx by gx. What would be remainder? What would be quotient? So there is a process. Okay. Sir, I have already shown in video. Let me revise it. So by this way you can do, just as you used to in this childhood, by this division. So how you will divide? Take the first variable here and divide with the highest degree of the term. So you will get x square. Just write in the quotient x square. Now multiply this x square with this x, whatever you are using the to divide it. So this is going to be your x, and write it to below of it. So this is going to be your x cube, and this is plus x square when you multiply x square with this one, and write it below of it. Now subtract it. So this is going to be cancelled out. There is no x square term in this portion. So this is minus x square plus 5x plus 1. Now again take the variable and divide with the highest degree. So this is going to be the highest degree. So this is going to be minus x. You divide with this. Now If you multiply minus x with this x, this is going to be minus x square. And this gives the minus x. Now subtract it here. This is going to be plus plus. Now this cancel out. It is going to become 6. And rest all become the same. 6 plus 1. Now again just divide x. Take x here. Take x, divide with this one. So this gives you highest degree term, which is 6x. So this gives 6. Now multiply, this is going to be 6x plus 6. Just subtract it here. Oh, I think I made a mistake, or x plus 1 is the root of this one. Maybe it is the root of. Okay, fine. So you get 0 remainder. That means x plus 1 is a factor of, or gx is a factor of fx. That means you can write fx as gx with the quotient, this one, x square minus x plus 6. So gx is our x plus 1. That means x plus 1 and x square minus x plus 6. That's the way that you can now factorize it. Now you can factorize this one also. So I don't know what is going to be factor here. But yeah, this is the factor. This is the process you will use to factorize a polynomial. I think what are the now next is in the polynomial. Division algorithm, I just now told you. Now zeros is a polynomial, just the roots. Now if you talk about here, x plus 1 is a factor. So what is going to be here? If you substitute x is equal to minus 1, this will become 0. That means the whole polynomial, that means whole polynomial gives 0 at minus 1. So actually x minus 1 is 0, you can say, or roots of the polynomial. So there are some other properties of these polynomials. Let me tell it here. So suppose you have a polynomial fx, okay? And let's say this is the expression is given. So let's say alpha is a root. And okay, it has some multiplicity. That means what it means that, let's say, let me write that. Let's say x plus 1 whole square, let's say, and this one, and x plus 1. Okay. Suppose your polynomial is this one. See that minus 2 is a root and minus 1 is a root of this polynomial. So, but there is a difference. Minus 2 is a root, okay, but it have two multiplicity. See that what it multiplicity means? X plus 2 times multiplied here. So that means it have two, x minus 2 is a root which have two multiplicity. And here is x plus 1 is a, sorry, 1 minus 1 is a root which have one multiplicity. Yeah, this is just a root. So there is one way. Suppose alpha is a root, okay? And if you want to draw the graph of this polynomial, suppose alpha have even multiplicity. Here is suppose alpha. Then if you draw the graph, it will be touches and bounce back. That's the mean of the even multiplicity. Around alpha, it will be touch and bounce back. If it is a even multiplicity, not even 2, more than if you suppose 4 or 6 or 8, it have 6 or 8 kind of multiplicity. Alpha is a root as even multiplicity. That's the meaning of multiplicity. If it is alpha is a root which have even multiplicities, such behavior of the graph will be such like this. It will touches and bounce back.
Sir,
yeah.
Sir, can you tell me how to count the zeros of this polynomial in graph?
So yeah, that's the zeros means roots of the polynomial. Okay. So how many zeros on this polynomial?
Sir, in graph.
In graph. So graph means just it will
Yes, sir.
intersect, no? It will intersect the x-axis. Suppose this is the graph of the polynomial. So it have 1, 2, 3, 4. 4 root zeros or 4 roots are there. 4 zeros are there. So how many times it intersect the x-axis? That number is that number of zeros in that polynomial. Okay. Now,
Okay, sir.
if suppose the that root is have the odd multiplicity, suppose beta is a root and it have odd multiplicity. What it mean that it is, let's say this polynomial have, let's say x plus 3 also in multiplication, let's say this have 3. So let's see that minus 3 is a root which have 3 multiplicity. If such things are happening, so the graph will be at minus 3, it will be behave like this. It will come and it will go like this. Like this it will behave. So odd multiplicity, suppose beta is a root there here. So it will behave like this. Okay. If it have odd multiplicity. And suppose here is 1 has only 1. There is no multiplicity, it have only single one root, minus 1. So it will be linear to, it will be look like linear. The graph will be look like linear. It will just pass like a line at minus 1. So these are the differences when have even multiplicity, odd multiplicity, or simple one root. Okay, this is all about in polynomial. And the next thing is, I think, going in the behavior of the polynomial. How will get that? So let me write very easily you can remember that. Let's say you have fx and I am writing as, let's say, a n x to the power n plus a n minus 1 x to the power minus 1, like this is 0. So let me write the category itself and tell you how you will get that, how the int behavior. What do you mean by the first int behavior of a polynomial? Suppose you are able to draw the graph of a polynomial, and what is going to be the expected as n goes to, as this is going to, x value is going to infinity. So int behavior is telling about this and how the graph is going to be there as x goes to its infinity. That's the meaning of int behavior. If it is going to negative as this one, or it is going to be bounce back and positive like this. This is the way. Okay. That's the meaning of here int behavior. So see that what is happening here. Suppose you have a polynomial, this one, and just consider this root and this, sorry, this degree and this first coordinate, sorry, first coefficient, the highest degree term. Consider about the highest degree term and the root, sorry, degree and the coefficient. This tells you something more. So let's say we have this one, xn to x to the power n, and suppose n is even. Okay, n is even and an is greater than 0. Okay, now if you substitute here some negative value, what it will give for value of x? What it will give? Suppose an is equal to 5 and n is equal to 2. Then it will become 5x square. So for what value it will be negative when it will become for negative, for when you give input, it will always be positive, right? So by this way, you can tell that, oh, so in the behavior based on the coefficients, highest degree coefficient and the degree of the polynomial. So in that case, you will say if x goes to infinity and n is even and this case is there, so x, then fx will go to positive value, positive only if this case is there. Suppose n is odd and an is greater than 0. In that case, again you can give an some value and check that what is going to be case. So in this case, what will happen as x goes to plus infinity or positive, fx will go to positive as an is positive and n is odd. But when x goes to negative and right side, left side of the real line from the 0, so fx will go to minus negative. Here I forgot to tell you as x goes to minus negative, see that as just now said, it will be always positive. In that case, fx will always still go to positive. So see, this is based on only the an is greater than 0 for both cases. Similarly, you can recall further when an is negative for both cases, even and odd. This is called in behavior of the polynomial. So this is, I think this is all about in a polynomial in the behavior and multiplicity of roots. I maybe I just quickly recall the FOIL method. What is the FOIL method? That is kind of error and trial method also. You can say FOIL method is just try to use. Suppose you have a polynomial fx is equal to, let's say, 6x plus 4. Okay. So how will factorize this polynomial to get the root? Why we are factorizing? Factorizes just directly visualize that what is going to be the root. That's why usually we factorize. How will factorize this polynomial? So just take the constant term, okay, and think about 4 can be written as 2 cross 2 or 1 cross 2 cross 2. That means you can take 2 and just substitute here is give 0, or take the condition minus 2 also, for plus 2 also and minus 2 also. Is this gives 0? I don't think it will give 0 when you substitute minus 2. Maybe let's see. 6 to the power minus 2 to the power 5 plus 3 into minus 2 to the power 2 the cube plus 4. Let's see that. What it happened? Minus 2 time, no, it will not give the 2. So minus 2 is not a root. So in this case, it will be very difficult to find the roots. So FOIL method, if you see that FOIL method is generally try to guess that. If you see that graph of a polynomial multiplicity will done, in the behavior we done, and graphing, okay. Where is that FOIL method? FOIL method we already did, no? Okay, in that quadratic it was 12. So division algorithm, zeros of the polynomial, graph of polynomial multiplicity. Okay, this is not, I was trying to, I thought maybe in this polynomial. So actually, a turning point, I just forgot to tell you. Am I audible? I just
Yes,
continue
sir.
speaking and
Yes, sir,
speaking,
you
no
are.
one is. Okay.
Yes, sir, you can proceed, sir. You are clearly
We are here,
share
sir.
your sound.
Okay. So last topic, I think, was just a turning point. I think almost I covered in the graphing. Graphing is just in the that in the behavior and the multiplicity of the roots. Now I did not tell you anything about the turning point. So till now, so that's all about the turning point. So turning point, what do you mean by turning point? turning point of a polynomial means just a polynomial. Suppose this is the graph of polynomial. The point is, this point is called turning point, where the graph of polynomial, from increasing to decreasing it happening, or either it is decreasing to increasing is happening. That's the turning point. So suppose if you have a degree of polynomial n, okay, degree of polynomial, and so it have at most n minus 1 turning point. That's the formula, and this you will get when you will study the calculus thing. Why this is true? Why it have n minus 1 turning points? At most n minus 1. If somebody says, suppose you have a polynomial of degree 5, and somebody says it have 6 turning points, so it will never have, because it have at most 4 turning points, not more than that. Okay, this is the final thing of about the turning point, and that's all about the turning points. Now I will stop my word, because from continuously 3 hours I am speaking. I don't know, all of you are maybe bored. I'm just speaking continuously. So this is all about, I just quickly recall the very fast. I don't know all of you got or not.
Yes,
Is
sir.
it clear, or yeah, just
Yes, sir,
revising,
we
because
got
this
Yes,
is
sir, got
just
it.
a
Yes,
revision.
sir, we got it. Sir, can you
So
take one question, sir?
yeah, sure. We'll discuss the last question, and then yeah. What is the question?
Sir, there is a doubt in the mock 1, mock 3, the last question, sir.
Mock 3.
Uh,
Is that mock? Mock is mock 3. Okay, do that. Okay, what is in which question number? Because this mock have solution already, so that's why I opened. Maybe if you are not know that, just go through the mock solution itself. Which question number?
last one, sir, last one.
Okay, this one.
Yes, sir.
Consider two polynomial, this one and this one. Define on interval this. A line passes through the x-intercept of px and the intersection point of p and q. Okay. So and this is just okay. So what's the problem here?
So that the coordinate x, the x coordinate of vertex, that 5.5, I'm not getting it. How?
5.5.
The third option, sir.
Is
In
this
the
one? This one. How it is 5.5? Oh, maybe in the solution it is written wrong. So let's say for the with respect to the polynomial, it is the x coordinate of the vertex qx. Qx is a quadratic. So what is the problem? Just if you want to find the vertex, just write in the fashion, no? 0.4 you have, and x minus 1, and what is that? X minus 10.
X minus 10.
Just multiply it. So 0.4.
Yes, sir.
This is going to be x square minus 10x minus x plus 10. So this is going to be your 0.4 x square, and this is minus 11 it will be. So maybe 0.44x, and this is going to be 4. Now the vertex is going to, if you want to find, just find the axis of symmetry. X is equal to minus b by 2a, which is minus b is 0.44 upon 2 into 0.4. So 0.44 upon 0.8. This is axis of symmetry. So now you can multiply with the 10 or 100, whatever you want to do. 4.8 by 8 it will be. This is going to be. Now we can, whatever, this is axis of symmetry. Now this substitute this value in the polynomial, you will get y coordinate. So that is going to be your 4.8 by 8, and whatever the y value f of 4 point or polynomial is qx, no? So q value of 4.8 by 8, 4.4 by 8, 4.4. This is your vertex. So what is that here? Your vertex is x coordinate of the vertex is 5.5 by 5. Oh, so means even this one, talking about this one. So what is that? 4.4 by 8. So no, so maybe this answer is wrong, maybe then. As here it is already. This is for 9, it is calculated.
Yes, sir. That's why I was not getting the answer.
Yeah, actually, because of this is kind of some other people used to get some other polynomial. That's why it is written a particular solution. Maybe, and also this is not 9 by 4. This is something. If it will not give 5.5, for 11 it will give 5.5. Here it is wrongness. Yeah.
Okay.
Okay, this is all about for the revisions. This revision session, I don't know, is it revises to the concept or not? I'm very fast because this contain week 1 to 4. If you people join with the first week, then I will try to cover first 2 week, and then in this today we'll try to cover the rest 2, 3, and 4. But in the single session we have to cover the all 4 weeks. That's why I extended it to 3 hour approx. Okay, this is all about for the revision for the today's session. Thank you so much. Anybody have doubt, please let me know. Otherwise, we'll close the session.
No, sir.
Okay. Thank you so much.
Thank you, sir.
Okay.
Thank you, sir.
Thank you very much.
And all the best for your next this reattempt qualifier. So just revise. Try to revise. Maybe QP can moderate or hard. It's just revise the concept. You will do that.
Yeah.
Try to do more.
One general question. We will get the examination link day before or on the day of it?
Examination link. No, you people used to go in the TCS center, no?
Yeah, I mean the same XCT link we have to use.
Oh, so if you will go in the TCS center, then what is the process to write the exam? That's all.
Remote proctored exam.
So is this going to be the proctored exam? I don't know.
I'm not in India, so I'm in.
Oh, you are not in India, so they will tell you. I don't know. No.
Okay. Because last
surely
time
it will reflect. Yeah.
Last time I did not receive any link. I sent emails and they told they sent an email, but I did not receive it. I checked my emails. I sent screenshots, but.
Okay.
Yeah. Okay.
So be careful with that. Okay. Be careful with this.
Whom should I contact? Like I wrote to support. I wrote to global engagement, but yeah, no response.
Okay. Maybe it will surely differ the link, and you will get the link in your mail, or I don't know how it is in the proctored exam. The process is totally operational query. I'm not sure about it.
Okay.
How it is.
Thank you.
Okay, thank you so much.
Okay, thank you, sir.
Good night to all of you.
Good night.
Good night.